CAP Theorem Elaborated. In order to get both availability and partition tolerance, you have to give up consistency. Consider if you have two nodes X and Y in a master-master setup. Now there is a break between network communications in X and Y, so they can't sync updates. At this point, you can either allow the nodes to get out of sync, giving up consistency. When they are out of sync, the data is not the same on both nodes. Or consider the cluster to be down, giving up availability. Technically, both nodes are not down. It is only that they no longer communicate. However, to maintain consistency, we consider the cluster to be down because they no longer are consistent. In such an eventuality, we lose availability. The clusters will no longer be available. Considering that we cannot have a database implementation that has all the three features, we are left choosing a combination of two at a time. The three possible combinations are CA, that is consistent and available. Data is consistent between all nodes as long as all nodes are online, and you can read or write from any node and be sure that the data is the same. But if you ever develop a partition between nodes, the data will be out of sync and won't resync once the partition is resolved. Consistent and partition tolerant. Data is consistent between all nodes and maintains partition tolerance, preventing data desync by becoming unavailable when a node goes down. Available and partition tolerance. Nodes remain online even if they can't communicate with each other and will resync data once the partition is resolved. But you aren't guaranteed that all nodes will have the same data either during or after the partition.